Hi everyone, you've seen the slides title by now, and you've also taken pictures of them. Thank you. So I'm Dan Dascalescu, I'm a developer advocate at Weaviate. We are a vector database, and I want to talk today about searching through large language model embeddings at scale. So what are these LLMs? They are large machine learning models that are specifically tuned for NLP tasks, which are things like generating text or classifying text or translation or Q&A. And you've heard of ChatGPT and Bing and all of these based on GPT 3.5 or 4, or Google's Bard, not so successful, but it's competing, or LLaMA from Meta. So ChatGPT in particular works at a high level like this. You send a prompt to OpenAI and it gives you a result. And this is an example of a prompt and the result are generated by it. You can see sometimes he hallucinates, but in this case, he detected that Christopher Columbus actually could not have visited the US a few years ago. Anyway, ChatGPT was extremely popular, and in, I think, a week, it reached 1 million users, and then it became the most used application ever, with 100 million users in 2 months, faster than anybody else. So it's a large language model that basically reads anything it can, and it has been trained on hundreds of billions of parameters. It has read code from all of GitHub. It has read novels, all the books that were available on public domain websites. And what it does is it's building a statistical understanding of language. It doesn't really understand language. So for example, in a Jeopardy or any sort of quiz like this, it could fill in these letters with another feather on your cat, because that actually does make sense if you look at the dictionary. It doesn't understand that it should be in your cap necessarily. But that's not a huge shortcoming because we can keep training them on larger corpuses. The biggest shortcoming of these large language models is that they don't have access to your private data, and you might not want to give them access to your private data. And it's a major limitation that you need to consider if you develop enterprise applications, because you need to ground the answers in your company's data for them to be relevant. So potential solution to this is to feed this large language model the relevant context, then the prompt, and the relevant context will come from filtered documents. So essentially, you tell the model, answer my question, and here's all you need to know. You need to know being a set of filtered documents. And you have the OpenAI logo there, the prompt, and the filtered documents will come together, and the OpenAI or other LLM would return you a customized response. And to do this at scale, you need what's called a vector database. And that's what Weaviate is. But in general, the process would be something like this. You have a set of documents, and you have your prompt, and you need something to filter those documents, and then submit them to the LLM, which would return the customized response. So this something, this question mark, is a vector database. And it has to solve two problems. First off, it has to understand your documents. And by understand, I have to put air quotes. And it has to search at high speed through them. Understanding is a difficult problem, especially if you want to do it at scale and in a secure way. And we do that with machine learning models that understand the context of data, and from that they derive some form of meaning. And here's an example of what I mean by meaning. If you look at keyword search in a set of documents like these, so let's say these are article titles or blog post titles. And the interesting one to us would be programming language for data scientists. And if a user types a query like Python, if you search for it in a traditional way, you're not going to find this post. Maybe you'll find something that contains Python literally. But if you search semantically for documents, then the results should include these programming languages for data scientists, because the meaning of that could be R or Python. So this is how this whole process works. You have the set of documents, and you have this encoder, symbolized by the AI here, that takes the text or image or sound or other data and returns these so-called embeddings, which are rather mysterious arrays of fractional numbers. mysterious because nobody understands what they are. This is the problem with explainable AI. And then if you represent these numbers in vector space, you end up with something that's very hard to visualize, but each concept ends up somewhere in this space. So I'm going to try to help visualize this in a simple way. First, if you think of colors, colors have these 3 numbers on the RGB spectrum. So you can actually represent them in a 3D space. Let me see if I can rotate this. And this is when demo gods are not on my side. Normally this rotates. Anyway, you have, oh, okay, it rotated. It rotates slowly. So you have colors that you can represent in this 3D space. And what you can see here is that they are close to each other in space if they are close in reality. So yellow is close to orange and close to pink and red, and blue is close to green. And that's not an accident, because if you represent them on these 3 axes of RGB, then by combining those numbers in an ink processing fashion, you're going to get close colors as they are represented in space. So intuitively, this kind of makes sense. Now, if you expand this to 300 or 1500 dimensions, that's how you represent concepts like cat or what we saw in the previous slide. And this is looking at 50 dimensions. This was a famous result from 5 or 7 years ago when we realized that we can have conceptual math, something like king minus queen equals woman, because that was the conceptual difference between these 2 entities, king and queen. And if you look at this diagram, you'll see that water, for instance, at the bottom is quite different from the other things. King and queen have these bits similar, and then humans in general have maybe this column here. We cannot say what exactly this means, but the model figured that maybe this means humanness or royalty. Okay, so moving on, this is a high-dimensional space, and then you have these arrays of numbers that we want to search through, and have to search through them fast, and you have to be able to scale this in production and also provide CRUD operations. So you have to be able to update and delete vectors, which models like Face don't provide. So that's what differentiates a vector database from a vector library. In a database, you can actually modify your data. So databases solve these challenges. If you're taking a photo, here is the slide again. So vector databases solve the challenge of storing and retrieving large amounts of vector data, and some of them of non-vector data as well, the original objects. And they provide scaling. So again, how a query would work is that we vectorize the input data. So in the previous example, the article titles. Then we vectorize the query. And if the query was kitten, it's going to be represented in the vector space somewhere near cat. And we find that using an algorithm called ANN, Approximate Nearest Neighbor Search. In particular, there's an implementation called HNSW, which Weaviate uses. So again, a vector database indexes and stores data objects optionally and their embeddings. This is how we differ from Pinecone, for instance, Pinecone being probably the most popular vector database. They only store embeddings. Weaviate stores data objects as well as embeddings. And this enables efficient similarity search or semantic search plus filtering. If you store the objects, you can filter for keys or properties in those objects, as well as doing the semantic search via vector search. So the vector DB will provide CRUD support and this efficient search using ANN algorithms. And in a nutshell, we store objects and embeddings, provide similarity and structure search, and update and delete support. So this is Weaviate in one line. a vector database that understands your data. And here's how a pipeline will work. You have this encoder, which would be a model like OpenAI or anything from Hugging Face, a transformer, or Cohere. I'm going to demo Cohere after the slides. So the model takes the data, and then a user query vectorizes both of them, and it produces a list of results. And what we wanted in our original quest was to provide that list of filtered documents to feed to an LLM as context. So the central element here is Weaviate, which creates this vector space and filters the documents, giving them as context for an LLM. And this is where Weaviate comes into the picture. So you have the documents. They go through Weaviate. It filters them. Then the prompt would get those filtered documents, and it will return the customized response based on your particular data set. So let's try a demo. Let's hope that works a bit better than the vector space. So this is a demo that we built by importing 10 million Wikipedia articles. They were vectorized using Cohere. And to keep in tune with that previous example, I ran a query for programming language for data science, and that returns R and Python. But let's do this live. So let's try something like something vague. What is the tallest thing in France? And I'm going to select all the languages here. So you can see it returned a bunch of things in different languages. And if nobody reads French, I'm going to limit us to maybe English. So of course it returns Millau Viaduct, which is the tallest structure in France, but also the Eiffel Tower, and then other articles that mention the tallest structure in France at various points in time. And I was going to search for Mont Blanc. So my query was for the tallest thing in France. Okay, Mont Blanc is a mountain. It's probably not what you meant, but it's still a thing. So we want to be more specific and say the tallest artificial. And now if I search for Mont Blanc, it's still there. So the model isn't perfect, but it returned this result farther down in terms of confidence levels, because we added artificial. And if we get more specific and say structure, let's hope that the mountain is no longer returned. Correct. And being the semantic search, we can ask things that are more abstract, such as what can keep things cool. And I did not know that acetone on dry ice, but that actually works. Then we learned about how the refrigerator was invented. So the idea here is that these large language models understand the Wikipedia article and store it somewhere in vector space near the idea of cool. And then our query is also somewhere in vector space near the idea of refrigeration or cooling, and they are close enough together that the search returns them. And the way this works is that we've loaded the data set through this pretty simple Python script. Make this bigger. You log into Weaviate with the Cohere API key, so you can vectorize incoming data. And then it's used to create a schema. In this case, the Wikipedia article only has one interesting field, which is the article body that we vectorize. And the other fields, like title, the URL, or the languages, we skip vectorizing them. So we only focus on the article body. And then to speed up processing, we have a batch import. Then this is actually how the data is inserted. So Cohere provides the data set in this library, which was installed beforehand. And then we pick up the embedded field from the data set and add it to Weaviate. and the other fields are just copied. So it's a pretty straightforward process, and at the end we make sure we import everything. This is the data set. And in Weaviate, you can play with your data in a very easy way using the GraphQL console. So here I reproduced our query from earlier. Let's try thing again. Let's see if we get a mountain. And the GraphQL interface lets you explore what fields are available. So here, if I press this, I'm going to get auto-completion. I can return the URL as well. So it's a very easy way to iteratively fine-tune your queries. And here we had the results in a bunch of languages because I hadn't filtered for that. What else? This is an interesting blog post I wrote, Vector Embeddings Explained, if that's fascinating to you. I was curious how exactly these things work, and I tried to understand it. This is what I came up with. Again, nobody truly knows how this works, but we have a bit of an understanding. And this was the end of my presentation. You can connect with us on our website at weaviate.io. We are also on GitHub under the weaviate.org and on Twitter at weaviate_io. I'm happy to take any questions. And I have my colleague here, Ken.
So I think you alluded to the differences between Weaviate and Pinecone. What are the primary differences? And there's another open source thing called Milvus. I think you may have heard of it. So what is the difference between, let's say, Weaviate and Pinecone? Was the question.
I'm not sure if the question was picked up by the microphone, but the question was, what are the differences between Weaviate and Pinecone, other than being open source? Weaviate supports this GraphQL API in addition to REST. So we think it's a very easy way to explore your data. And besides GET, we have also aggregation queries and exploration queries. We also support modules. Let me pull up the docs here, actually. So we have a variety of modules, which we grouped into vectorizers. So you can interface with Cohere or OpenAI or Hugging Face or any transformer. Also, it's multimodal. Then the results can be piped through an LLM, which is called generative search. So there's an operator here that lets you pipe results back through OpenAI, which was the prompt example from the beginning. Summarization modules in ER. Client libraries, I think we are on par with Pinecone. We have a more transparent pricing model. So you can estimate here how much it would cost you. Let's say we use OpenAI embeddings, and they're going to have a million data objects and something like 100K queries. That's about how much it would cost you. Yes?
What is your current integration with ChatGPT? Because Weaviate has been mentioned in the plugin article. And I was wondering, like, are you only providing on-premise, or do you have like other mode of integration with ChatGPT?
So there is a ChatGPT retrieval plugin. I think it's that one. I haven't looked much into this, but I know it was developed by my teammates. Do you know more about this plugin?
Yeah, to address both of those questions together, my name is Ken. I'm also I look at it a little bit like Splunk versus Elasticsearch. I was at Elasticsearch for 5 years. I've used it since 0.12. I love it. Both great products. Splunk is very top-down. Elasticsearch is very bottom-up, right? If you had your needs fulfilled from the top down by Splunk, great. If you didn't, you can put it together yourself with Elasticsearch. There's slightly different audiences that we're aiming at. To that point, Weaviate attracted me because it's a very bottom-up solution, toolkit that we nerds can put together what we want. You can host your own inference models. You can use hosted inference models. You can train on your own GPUs. You can train on your own whatever. It doesn't matter. So it's a slightly different audience. To that point, yes, we do have a generative OpenAI module, as we call it, that lets you do kind of a Q&A also we have a module for with ChatGPT, as well as just using a vectorizer that uses the same models that ChatGPT itself, essentially trained on. All of the Ada, the Michi, ChatGPT 3.5, 4, everything. So it's more of a bottom-up approach, and to the point of ChatGPT, we have different modules that approach that in different ways, including just vectorizing your own data using the system models that ChatGPT is essentially using. So, yeah.
Thanks.
Pardon me, this is just the first presentation I heard about it, so it might be a question that's out of scope. But what are the responsibilities between Weaviate and the different units that do the encoding and providing the vector embeddings themselves? Well, Weaviate's also doing the query processing and the result set. So I saw named entity recognition fly by, and I was curious about disambiguation. Mont Blanc could be both the mountain or it could be the maker of the pens. And so is there an aspect of the search and retrieval model that in the query allows you to cluster the responses and say, I've got a big chunk of things that are about Mont Blanc, the Mont Dev, because only given that search term, and a different one that's a vector headed in a different direction?
Go ahead, yeah.
So the simple answer is yes. The actual answer is a little more complicated, as it always is in search, right? Everybody sees Google as a box. It's really simple, right? There's one guy back there answering all the questions. There's blending going on. There's 17 different data silos that are being talked to, blah, 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 blah. So to your specific question, one of our pieces of functionality is aggregation. Because we're familiar with that, it's faceting or aggregation, group by, right? It's a cool way, in a way. And so the not so simplistic part of it is that your data needs to support that sort of operation, right? If you wanted disambiguation on Mont Blanc versus whatever, but you can tokenize things in a very flexible way. We're working on data pipelines for the ingestion part of it, as you're probably aware. There's ingestion and query time, parsing, that sort of different functions in this world. So yes, it's as with anything, an ongoing project, but yeah.
Glad here you can build it from bottom up.
Yeah. Garbage in, garbage out is, I think, another answer to that. So the better your data supports it, the more we can do with it, but aggregations are where I'd start.
Question back. It's a little bit related to that last question, actually, which is sort of like for like hybrid recommenders. So where you want to do some hybrid of ANN with HNSW, and you want to do text search, and you want to blend. How much capability do you allow for sort of like blended indexes or other approaches to this?
Full hybrid search support. We have vector plus keyword search, if you want to simplify it, right? Kind of traditional TF-IDF. We use BM25 out, so if you're familiar with it. Yeah, so hybrid search, you've got an alpha that you can steer things between. I don't really need to in practice, to be honest. So, yeah.
You said a single printer?
There's a couple, but yeah, there's a bias, right? Alpha is the bias too. And yeah, there's a few other parameters there, but again, that's another area that you're skirting the line between the search engine and the database, right? Search engine does a lot of or gives you the capabilities to do a lot of the pre-processing of data, right? To pull out things that you might want to filter on. I mean, that's a front end. It almost always is. So we're not attacking that at this moment. There's no need to it. But once you do that, we fully support that as inputs.
Any other question?
Yeah, thanks. We know there are so many ways to do index, like you mentioned, there are hybrid mode. So as a user, maybe we need some tool for evaluation or how, for example, every company have their proprietary data. They might have the decision they should store some way. Do you have any advice or any tools for evaluation?
Talking to I'm on the solutions engineering team. I know that's a dirty word. I come from the engineering world. I just find consulting to be interesting because I like seeing other people's problems. So it's a journey, I've always called it, right? You start with the documentation, it's self-serve, and then you start with kind of self-serve tutorials, educational materials, things like this, official 3-day workshops, that sort of thing, and then professional services. That's one way of doing it. Our community is great. Actually, our Slack is getting actually a little untenable at this point. So yes, there's no magic answer. There's no, well, we do have a configurator that guide you. But there's no magic way to know per se. There are tools for that, for sure. But yeah. That's not our core business.
All right. Thank you, Dan. Thank you, Ken.